All right, the last thing to note in the first section, I don't know how low you can see the board, so let me erase this here. Take a look at the bottom of page 237. And look at the powers of I. Also take a look at example 4. It should be pretty self-explanatory. Just make sure you're familiar with it and know how to answer questions of that type. All right, section 2. In section 3.2, we start talking formally about quadratic equations. And a quadratic equation, these markers are going to be the death of me. A quadratic equation is an equation that can be written as ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not equal to 0. Because if a were 0, you would zero out the squared term, and all of a sudden you just have a linear equation, and that's not a quadratic. They're very different. Now, a really important note is that when we're working with quadratics, particularly when you're starting to factor them to solve or using the quadratic formula to solve, you need to make sure that you have your equation set equal to 0. Sometimes it's obvious to people, sometimes it's one of those little nuances that slips the mind and it totally just screws up whatever work you're trying to do. Now, as stated before, the solutions to a quadratic are the points where the graph crosses the x-axis. Now, there are a couple words that are used when you're being asked to find the solutions. If you're asked to find the zeros, you're being asked to find where the graph crosses the x-axis. If you're asked to find the intercepts, you're being asked to find where the graph crosses the x-axis. If you're asked to solve, you're being asked to find the values of x where the graph crosses the x-axis. So all of these words mean the same thing. And there are a number of ways that you can solve a quadratic equation. You can either use roots, you can use factoring, you can use completing the square, which is another way to factor, and you can use the quadratic formula. Any of those will be fine. Okay. There are really nice examples on page 1 and example 1 and example 2 on page 242. And what they go through are how to solve a quadratic and how to check your solutions and what you're actually looking at visually. And I think it's a nice exercise to go through and solve them and see what the graph looks like and try and make that connection that when you're solving a quadratic, you're looking for the points along the x-axis where the parabola crosses. Those are well-written examples in the textbook. Again, page 242 and 243. Now, the quadratic formula is written on page 247. And just to review what that is, where's my spray? Quadratic formula is as following. It's the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And these a's, b's, and c's come from the definition of a quadratic equation. We said that quadratics are written as ax squared plus bx plus c equals 0. So once you set your quadratic equal to 0, your a is the constant before the squared term, your b is the constant before the singular term, and your c is the constant hanging out at the end. Now, b or c can be 0, but don't forget a cannot be. So just to run through a quick example, we had 3x squared plus 2x equals 7, and we wanted to solve this using the quadratic formula. The first thing we would have to do is set it equal to 0. So, subtract 7 from both sides. You now have 3x squared plus 2x minus 7 equals 0. Your a is 3, your b is 2, and your c is negative 7. It's important to note that you take the sign with the constant. So then it's just a matter of plugging these things in. We will have the opposite of b, which is negative 2, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. At this point, you just start working under the root sign. So now we have negative 2 plus or minus the square root of 4 plus 12, 21 times 4, 84, I think. Yeah, 84. Divided by 6. So then x is now equal to negative 2 plus or minus the square root of 88 divided by 6. And then you want to simplify your root as much as possible. So I see that there's certainly a 4 in there. I can write it as negative 2 plus or minus 2 square root of 22 divided by 6. I don't see any more perfect squares under the root, but I can simplify the 2's here, so I can rewrite this as negative 1 plus or minus the square root of 22 divided by 3. I divided all 3 by 2. Okay? And then at this point, since 22 is not rational, you can just leave it. That's fine. Should be good enough. All right, now within the quadratic formula, we have something called the discriminant. And the discriminant tells you how many real solutions you have to a quadratic equation before you even solve it. So the part of the discriminant, or the part of the quadratic formula that is called the discriminant is b squared minus 4ac, and it's set equal to 0. Okay, if it's set equal to 0, this tells you that you have one solution. If it is greater than 0, this tells you that you have two solutions. And if this is less than 0, what you have are either no real solutions. Or you can say that you have two imaginary solutions. So again, before you even delve into trying to solve or find the zeros or etc., you can use the discriminant to tell you how many solutions you have. On page 252, there's a little box called Connecting the Concepts. And I think it's worthwhile to spend a minute looking at that, looking at the difference between the linear and the quadratics, and just trying to tie everything together in terms of finding solutions and how that looks graphically. So you could take a second to look at that. It'd probably be worth your while. All right, section 3, third section here.